Today we're going to take a deep dive into Fusion 360 and I will show you how I designed these 3D printed 7-segment display panels. Welcome back to Cloud 42, I'm James. Last week I spent some time testing the Bamboo Lab A1 Mini 3D printer and I used these 3D printed display panels as a challenging test to see what the printer could do. Now these panels have 3 different materials. There's a black PETG for the body of the panel itself. There's a clear PETG material for the lenses for the 7-segment displays, and there's a single layer of white PETG behind that as a diffuser. This was not a simple part to model, and in the video last week I just completely glossed over that process, but today we're going to look at how I did it step by step. Stick around and maybe you'll learn something interesting. Before I jump in though, let me answer the #1 question that I get on all of these videos. I'm navigating in Fusion 360 using a 3D Connection SpaceMouse. This is a 6-degree of freedom input device. You just grab the knob and it allows you to twist and rotate your model, zoom in and out, and control the camera essentially while you're working. They make a whole bunch of different models, from the simple SpaceMouse Compact that just has essentially the 6-degree of freedom joystick, all the way up to the enterprise version that has a whole bunch of programmable buttons and little displays. I don't use any of that. I just have the SpaceMouse Compact. I have a wired one on my workstation, and then I also have a wireless one that I take with me on the road. I'll put a link to this down in the video description. But again, that is the #1 question that I get when I show Fusion 360 in a video. This is the part we're going to model, and we need to first establish a bunch of geometry. We're going to need a sketch to lay out the segments of the digits, and we're going to need a sketch to lay out these shields on the back. And it's a pretty complicated sketch, but we'll just start with the simple core of it and add the complexity as we go. So the first thing that I did is I defined a bunch of parameters. I want to be able to come back later and change the size of the digits or maybe the angle of the digits. So I've got the italic angle in here, 7 degrees. I've got the height of the digit, 12 millimeters. I've got the gap. That's the gap here in the corner between the segments. I've got that set to 0.5 millimeter. I've got the segment width of 1 millimeter, and then I've got a bunch of other parameters in here that we'll use later in the modeling. And I kind of worked through this once and figured out what these needed to be, but I did this progressively, starting with just the angle and the height and the gap, and then just added them as I went. So let's start with a sketch and set up the basic shape of the digit. So I'm going to hit L for line, X for construction, and we'll just go ahead and draw the shape of the digit. Now, as I move this back and forth, you can see it snaps into position there with a parallel constraint, and that makes those lines appear parallel, so I don't have to come back and put that constraint on them later. And so now I've got that, and I can come up here and find the midpoint and draw the center line across, snap to the midpoint, and now we have the basic shape of the digit. I'm also going to put in a vertical line here, hit escape to stop drawing, and start putting some dimensions on this. So D for dimension, and then the first thing we'll set up is the height. And then I want to make the width half of the height. So height divided by 2. And then the italic angle we can set between this vertical line and the side of the digit. And now we have the basic shape. Now, of course, I can come back here and modify the parameters at any point. If I decide that I don't want 7 degrees, I want that more, I want, say, 9 degrees, I can just change that and that angle will change. I'm going to leave that at 7 though. I think that looks nice. And now we need to define the borders of the segments. So I'm going to do that with the offset. So hit O for offset. Chain selection is turned on. So if I select the outside of this, it's going to offset at some distance. I'm going to turn off the construction line. So this will be solid. And then the distance that I want is going to be the segment width divided by 2. And I will offset to the inside minus segment width divided by 2. And that gives us the width of the segments. Now there's more going on here, right? That gives us the inside and outside lines of these segments, but there's more than that. The segments through there, I need the inside and outside width of the pocket for the LED. And then I also need another border even further out from that to cover the thickness of this wall. So we'll go ahead and add those. Offset again, in this case, the LED width divided by 2. O minus LED width divided by 2. And then we need the wall out beyond that. So that will be O for offset, LED width divided by 2, plus the gap. And offset the other direction as well, minus LED width divided by 2, minus the gap. And that gives us all of those borders, at least around the outside. We also need them on the inside here. So I'll do exactly the same with this center line, offset. Okay, that gives us all of the borders. Now around these segments, we need to draw in these diagonal lines that will give us the gap. And we'll start with just some construction lines. I'll hit L for line, X for construction, and we'll just go corner to corner across these guidelines that we started with. And then we need to offset from those half of the gap on each side to then define the segments. So we'll turn off the construction, offset, gap divided by 2, minus gap divided by 2. I'll just do this for all of these lines. Now this is starting to get really messy, but don't worry, it's going to get even messier. So we need to define the other side of these segments, and to do that we need some points. So I will say create point, and I'm going to come in here and put these points where the corners of the segments will be. So where these gap lines intersect with the center guideline. Now it looks like I missed a couple. And now I need to come back and define the other side of the segment. So the segment is in this region here, and there needs to be a line across here. So hit L for line. And what I'm going to do is I'm going to pull it all the way out to here because I know I need it to come this far. And I'm not snapping it parallel to anything. I want to come back and do that later. So I'll just go ahead and put all of these in. Okay, I think that's all of those. And now I'm going to come back and click on the parallel constraint, and I'm going to bring all of these lines parallel to these center guidelines. And I put them in there without any constraints initially, just because it's so hard to get them to snap to the right other line in something that's this busy. But when we come back and do this after the fact, we can be selective. And the last thing we need is an outer wall, just like we've got this outer wall that's going to go around the outside of the pocket for the LED. We need to define this line that's on the outside edge of this wall. And we're going to do the same thing. We're just going to put it in without any constraints, and then we'll come back and constrain it. Okay, so we'll say parallel. And then we'll hit D for dimension, and we'll offset this from here, the gap. And do that all the way around. Now for these lines that cut in on the side, again, that's these two lines right here. Fortunately, we know those need to line up with the inside ones, so we can just use a collinear constraint. And I can just click those and line those up quickly without any measurements. Now that we have this completely unwieldy sketch with everything in it, let's create some simpler sketches and just project some of these lines into it just to make our job easier. I'm going to start by creating another plane here. We're going to offset this by the PCB clearance plus the panel width, panel thickness, and that'll create another plane on the back here. And what I'm doing is the sketch is on the front plane, and this second plane is the back end of these extrusions on the back. And I'm going to create a sketch on that back plane, and I'm going to hit P for project, and we're going to project some of this geometry back there. Not everything, just the outline that we actually need to extrude. Okay, that's one sketch. I'm going to go ahead and hide that one, and I'm going to create a second sketch back there as well. And I'm going to project more geometry onto the second sketch. And specifically on this second sketch, what I'm projecting is the geometry I need to carve out the holes for the LEDs. And I think that's everything I need for that. Okay, so let's turn on just this back sketch. I'm going to select the regions here that I want to extrude, click and control click, hit E for extrude. Extent type, I'm going to say to object, click something on this front plane, and that will then, if I turn the sketch off, you can see that extrudes a solid block of plastic, which is the material that's going to completely surround these shrouds on the back. Then if I turn the front sketch and that third sketch we did on the back on, that gives me everything I need to loft the openings. So this is a segment on the front, and then on the back, this is the opening for the LED. So I can come up here and say create, loft, select the segment on the front, the opening for the LED on the back. It'll default to cut, click OK, and it will carve out that tapered opening from the front to the back. And then I can just go through and do exactly the same thing again. Loft from the back, in this case to the front. And we'll just go through and do all of these. Now the one in the center is a little bit more complicated because of all the extra lines in here. There are a bunch of different profiles. So what we'll do is I'll start and say create loft. I'll click one of these profiles, and you see it's created a single profile here in the loft command. Now I'll hold Control and click the rest of the profiles that I want included on the front side, and you can see that there's still only one profile. Then we'll flip around to the back, and I will not hold Control, click, that will create a second profile. Now I'll press Control and select the rest of the profile. Release Control, click OK, turn off the sketches so you can see what's going on, and that has carved that segment through to its LED pocket on the back. So we have all 7 segments carved through the back with these tapered openings, and that's exactly like what we have on the back of the finished panel here. Well, that was by far the most complicated part of the model, and the rest of it should be relatively easy. So I don't want just one digit, I want 8 digits in 2 groups of 4. So I'll come up here and click rectangular pattern. I'm going to pattern bodies. I'll select this body. On the axes, I'll select this bottom line because I know that that's horizontal. In fact, instead of that, I'll go ahead and select the x-axis here. And I want to distribute these by spacing. I want 4 of them. And the distance should be the parameter I already calculated, which is digit spacing. Okay, and that gives me 4. Now these are separate bodies. You can see they're overlapping right here at the wall. And so to join these together, I will go ahead and click Combine here and Target Bodies. Select the first one, Tool Bodies. I'll select all the rest of these. And I want to join. I don't need to keep the tools. Click OK, and now we have a single body with 4 digits. If we come over here and look at our bodies, there's only 1. And so I can do exactly the same thing to make another group. So object type bodies, select this body. Axes, we'll select the x-axis. In this case, I want 2 of them. And I'll just drag that over. I think I have a parameter for that, but it doesn't really matter. So there are 2 groups of 4 digits each. So the next thing I want to do is put these into a panel. And to do that, I need a sketch. So I'll say create sketch, and I will just select the front of this. Now I do need the geometry here, so I will hit P for project, and I'll go ahead and just click on the front faces of both of these so that the geometry will be included. And that'll allow me to do fun things like creating a line. So hit L for line, line type construction, and I'm just going to draw a diagonal line across between these, and that way I'll have a midpoint here, and I can drag up that midpoint and just hit escape. We'll use that here in a minute. Then I can come up here and say create rectangle, and I'm going to create a center rectangle and use that point and drag out and create something that looks sort of like a control panel. And I can move this up and down to where it needs to be, and see that center point that's going to be centered between the digits is moving around, and I can define this however I want. Let's go ahead and put some dimensions on it, say 100 millimeters by 60. And then we can define the vertical position. You know, we'd like to put this in a place where it'll be repeatable and can be controlled. And so I'll just put that about where I think it should be. And then we'll just throw a dimension on this line. D for dimension. And we'll just call that 8 millimeters. And the only reason I put that on there is so that everything will be locked down and we can come back and move that later. Okay, finish sketch. I can select this region, and then I'm going to control click the profiles in the center of the digits because I don't want those holes. Hit E for extrude. And it looks like we're going in the minus direction, so I'll say minus panel thickness, and we'll make sure that's set to join. And now we should have a single body that has all the geometry we need. And it looks like I missed these holes, so let me double click to reopen that, and I'll just come through and control click those diamonds as well. And that gives us a panel with the digit openings with the shrouds on the back that go down to pockets for the LEDs. Now I'd like to put a nice border around this, so we'll create a new sketch, put that on the back, project that surface, offset the side here by what? Let's call this 1.5 millimeters. Finish that. E for extrude. Distance to object the same height as these, and give us a nice little wall around the outside. And then let's fillet this. I'll select the whole bottom surface here and say 1 millimeter. That looks nice. Now hit F for fillet again. We'll put some fillets around the outside. And on the inside, I'll make these say 2 millimeters. And I'll do the same thing on the outside and make those the same 2 millimeters plus the 1.5 wall thickness. So 3.5. Make sure I've actually got the lines and the corner selected. Okay, that gives us a nice panel. Beautiful. Now that we have the panel with the openings for the digits in it, we need to model some lenses. And before I do that, I want to start using components here. So I'll right click on this body, say create components from bodies, and then I'll have a component here and I'll rename this panel. That will allow me then to create a new component for the lenses. To model the lenses, I will start with a sketch, and I'll put that on the front panel here, and I will hit P for project, select the front panel, and then click OK, and that will bring all of that geometry into the sketch. And I'll just go ahead and finish that. Now having that sketch then will allow me to select these individual regions within the digits. Without that sketch, that isn't possible. So if I scroll back the timeline to before the sketch, you can see those don't highlight because there's nothing there. I'm just highlighting the things that are behind it. But if I have that sketch, then I can select those. So let me select them all. I'm just going to click and control click and select all of the digits, or all of the segments in all of the digits. Now with all of those selected, I'll hit E for extrude, and we want to go minus the lens thickness. Let me turn off the panel here so we can see what we're doing. That's extruding straight down. I'd like those to be tapered out, and I have a parameter for the lens taper. So instead of extruding straight down, those are going to extrude outward, and I want to say new component. Click OK, and that'll create a new component here, which I will call lenses. So I can turn on the panel, and I can turn off the lenses, and we can see that those are separate components. And within the lenses, there should be a whole bunch of bodies. Looks like 56 bodies. Now, if we say inspect section analysis, and click on the front here and just drag this back, and then zoom in here, you can see that the lens is overlapping with the panel. They're both occupying the same space. If I turn off the panel or turn off the lenses, you can see that they are overlapping. The lens is actually keyed into this because the taper is steeper than the taper of the pocket. And I would like to make a cutout in the panel to accommodate for that. So all we have to do is come up here to combine, and the target body will be the panel. The tool bodies, we need to open up the lenses, and I will click the first one, scroll all the way down, shift click the last one, and we have 56 selected, and then I will choose cut. And importantly, I want to choose keep tools so it won't delete the lenses. Click OK, and that should have done what we needed. So now if I turn off the lenses and we go in here and look, you can see that it's actually cut out a pocket for the lens to fit into. We turn the lens back on, it fits neatly into that pocket. And if we look at a cross section, you can see it more clearly. There's the pocket, and there's the lens that fits into it. And then if we want to put another layer on the back of this as a diffuser, we can just do exactly the same thing. I'm going to go ahead and leave that section analysis here and just turn that off. So if I just turn off the panel, then we can come back here and just select the backs of all of the lenses. And I'm just control clicking to select all of these. With all of those selected, I'll hit E for extrude again. And for distance, I'm going to say 0.2 millimeters. I didn't actually create a parameter for this. I probably should. Same lens taper. And the operation is going to be, again, new component, so that it will create a new component for the diffusers. And I'll rename the new component it created Diffusers. So now we've got the lenses, the diffusers, and if I turn on the panel and then turn on the section analysis, you can see we've got exactly the same situation that we had before. The lenses are cut into a pocket, but the diffusers are overlapping. So we'll do exactly the same thing here again. Combine, target body is the panel, tool bodies, we'll open up the diffusers, select the first body, shift select the last body, leave keep tools on, and that will cut out a nice pocket. So we can turn off the lenses, turn off the diffusers, and you can see there's a pocket for the two of them to fit in there. Let me apply some colors to this. So I'll right click up here, choose appearance, and let's just take, here's a glass medium colored blue. I'll drag that onto the lenses, and the diffusers, phenolic amber, I'll just drag that on here. And there we go. So now you can see the difference between those. If we turn off the panel, you can see the lens, the diffuser, and the panel around it. In the original video for this project, I also showed a block diffuser. If I turn off the panel here and turn off the lenses, these are the diffusers that I just made. These are one layer thick. and are behind the lenses. But I also created a version of this that had a block diffuser that was across the entire thing. And I'll just show you how I did that. So I'll roll this back. Here is the extrusion operation that created the individual diffusers. I'll roll back before that. In fact, I'll roll back before the component creation there, and I will create a new sketch. We'll just put that on the front plane here, and we'll just put a rectangle in the sketch, and that is it. Now we'll roll forward after that extrude operation. I'll double click that, and you can see right now we have 56 profiles selected. I'll just turn that off. I'll select this one profile, and then start. I want to start from an object, and we'll just go ahead and select the back of the lens. It'll be the same 0.2 millimeters, except we need to go minus. And we don't need a taper. And that will be a new body because that new body is being placed in the component. When we created the new component previously, it created a component and then put the bodies in it. This, I'll just say new body, and this will leave us with the diffusers object with only one body in it. And if I turn these off, you can see that's the large block diffuser. If I turn on the lenses, they're on the front of it, and then the panel is around the outside. We'll go forward across that combine operation. I need to double click and open that because previously the tool bodies, there were 56 of those. Of course, those are all gone. There's only one left. So now, it's showing a warning because they're missing, but now that I've opened it, it's updated that selection. I can click OK. You can see the warning is gone. And if we turn on the analysis here, you can see that the diffuser is all the way across embedded in the panel. And if I turn off the diffuser, you can see that there's an empty slot in there to provide space for it to occupy. And this thing should then be ready to 3D print. Now, in the video last week, I did go through the process of showing how to do this. In short, we're going to use the components to output separate STL files. So we'll say File, 3D Print, choose my format as STL, and then I have to select something to output. And you can use the components to do this simply. So I'll select the panel. I'll output that as an STL file. We'll come back in here, 3D print again. I can select the lenses, and it will select all 56 of those bodies and output them in a single STL file. And then we can come back and do it again and select the diffusers. And it'll either be the one body we have here or 56 if we have the separate diffusers. Now, I did get some questions in the video last week as to why I output them as STL. Why didn't I just say 3MF and just select everything? Well, you can do that. And if you output a 3MF file and then you bring that into Bamboo Studio, that will work. However, every single body is going to show up separately in a flat list. So we'll have 58 bodies here, and you won't be able to just say, oh, I'm going to select the lenses and make those a particular material. You're going to have to go through and find all 56 of those lenses and set the material on them individually. Now, there might be a way to do this with step files or with something else that will maintain the hierarchy so that you can select just the lenses and apply something to all of the bodies. I couldn't figure out a way to do that, so I just did it with STL, and this is a pretty safe way to do it that will work in pretty much any slicer. And for the details of setting up the slicer and setting up the different materials for the different objects or the different bodies, check out last week's video. Again, I went into all the detail about how to assign the materials and how to have different settings for each material. I hope you found that useful. Not everyone loves a deep dive into the CAD, but I know I do. I learn a lot of new tricks and tips by watching other people work. If you enjoyed the video or found it useful, give it a thumbs up. Feel free to subscribe and consider supporting the channel over on Patreon. Patrons can download the files for this and all of my other projects. And if you're already a patron, thank you. You make it possible for me to do this. Thank you for watching.